Good morning. Hope everyone is enjoying their time at home. When we last left off, we had just finished section 19.1 about earthquakes, their forces, their faults, and their types of waves. So where we're picking up is at the beginning of section 19.2. So for today, we're supposed to read pages 534 and 535 and then take notes on that information. So what I'm going to do in this video is read the text for you in case you would like to follow along with your own chapter copy at home. Seismic waves and Earth's interior, section 19.2. Seismometers and seismograms. Most of the vibrations caused by seismic waves cannot be felt at great distances from an earthquake's epicenter, but they can be detected by sensitive instruments called seismometers. Some seismometers consist of a rotating drum covered with a sheet of paper, a pen, or other such recording tool, and a mass, such as a pendulum. Seismometers vary in design, but all include a frame that is anchored to the ground and a mass that is suspended from a spring or wire, as shown in figure 19.7. During an earthquake, the mass and the pen attached to it tend to stay at rest due to inertia, while the ground beneath shakes. The motion of the mass in relation to the frame is then registered on the paper with the recording tool or is directly recorded onto a computer disk. The record produced by a seismometer is called a seismogram. A portion of one is shown in figure 19.8. So that's the seismogram at the top there. That's the paper. Travel time curves. Seismic waves that travel from the focus of an earthquake are recorded by seismometers housed in distant facilities. Over many years, the arrival times of seismic waves from countless earthquakes at seismic facilities around the world have been collected. Using these data, seismologists have been able to construct global travel time curves for the arrival of P waves and S waves of earthquakes, as shown in figure 19.9. These curves provide the average travel times of all P and S waves from wherever an earthquake occurs on Earth. Distance from the epicenter. Note that in figure 19.9, as in figure 19.8, the P waves arrive first, then the S waves, and the surface waves arrive last. With increasing travel distance from the epicenter, the time separation between the curves for the P waves and S waves increases. This means that waves recorded on seismograms from more distant facilities are farther apart than waves recorded on seismograms at stations closer to the epicenter. This separation of seismic waves on seismograms can be used to determine the distance from the epicenter of an earthquake to the seismic facility that recorded the seismogram. This method of precisely locating an earthquake's epicenter will be discussed in section 19.3. All right, stay tuned for the next video in which we will take notes